Hello and welcome to this question that goes through inequalities question. So we need to solve the inequality of minus 6 is less than or equal to x squared plus 3x minus 4, which is less than 6. And then we're going to follow the hint, so solve as two different inequalities that use a number line to find the values that satisfy both inequalities. So we'll start by writing out our equation. So minus 6 is less than or equal to x squared plus 3x minus 4, which is less than or equal to 6. So we're going to solve each one separately. So minus 6 is less than or equal to x squared plus 3x minus 4. From here we can rearrange. We can 0 is less than x squared plus 3x, and then we're going to add 6 to both sides, so plus 2. And then we're going to rearrange this one so it becomes x squared plus 3x plus 2 is greater than or equal to 0. We're then going to factorise, so it's going to be x plus 2, x plus 1 is greater than or equal to 0. So that means that if it's equal to 0, then x is equal to minus 2, x is equal to minus 1, when y equals 0. From here we can then solve by drawing out our equation and showing where it crosses the axes. So it crosses at minus 2 and minus 1, and we can draw our curve. So if we draw our curve and then we look at our inequality, so we're looking for when it's greater than 0. So here for this part of our inequality is going to be x is greater than or equal to minus 1, and it also is above the y-axis when it's less than 2. So we're going to say that it's also x is less than or equal to minus 2. Now that's not our answer, that's only the first part. So the next part then is we're going to look at the other side, which is when x squared plus 3x minus 4 is less than or equal to 6. We're going to move the 6 over to the other side, so it's going to be x squared plus 3x minus 10 is less than or equal to 0. And then from here we're going to factorise this one, so this is going to be x plus 5, x minus 2 is less than or equal to 0. So when y equals 0, x is equal to minus 5, 1, 2. And then from here we're going to draw this out. So it becomes, this is minus 5, this is 2, and we can sketch our graph here. And we're looking for the points where it is below the x-axis because it's less than or equal to 0. So it's going to be here. So these are all the points of the graph here are negative y points. So therefore our range here is going to be minus 5 is less than or equal to x is less than or equal to 2. Now we're going to refer back to this part here, and we're going to find where the intersection occurs for each one. So for this one here, if we look at the number line that we have, so here we're going to find, so we've got two inequalities and we want to find where exactly they're going to lie. So the first one here is that x is greater than or equal to 1. So here that means it's going to, minus 1. So it wants all the values essentially that are greater than minus 1. So we're going to say it's all of these values here. And then for x is less than or equal to minus 2, it's going to be all the values that way. And on the same number line, we're going to look at this one. So here it's between 2 and minus 5. So it's going to be minus 5. And then it's going to be also to 2. So we can see here that there is a gap in our first one, which means that we can create our first inequality here, which is that minus 5 is less than or equal to x, which is less than or equal to minus 2. So there's a set of solutions that can lie here, and there is also a set of solutions that are between minus 1 and 2. So it's going to be x can exist between minus 5 and minus 2, and x can exist between minus 1 and 2, and they're the only values that it can exist. So that is essentially your answer, and we solved the inequality.